Hi everyone, so we'll be doing another one of these scheduling examples and questions. So the question says, do scheduling of a sprinkle irrigation by calculating the following with the help of the table of delivery and given values. So these are the given values: root depth, soil capacity, or water retention, whichever you choose, evaporation, effectivity of the sprinkle irrigation system, the crop factor, and then the average rainfall per month. And here's the table. So you've got an emitter spacing of 7,5, emitter delivery, and wet diameter, which is important. Okay, so this first part says determine the evaporation in the month of February. So we know that evaporation is calculated with that Class A evaporation pan. So if you go back to the beginning, it says that the evaporation in February, so that line there, was 3,2 millimeters per day. So the evaporation is going to be, and that was out of the Class A pan, so it's going to be 3,2, okay, multiplied. So that was per day, and we want it for the month of February, multiplied by 28, and then we have a crop factor. And so for this crop, it is 1,2. So that's time 1,2. And so if you put all of these values in, you'll get an answer of 107,52 millimeters per month. Okay, so that is your evapotranspiration for the whole month. Okay, so the next one is effective rainfall, and like we know from one of the older videos, effective rainfall is the rainfall that you could actually that actually ends up on the soil and can be used by the plant. So that is the monthly rainfall, which is right at the bottom. It says that rainfall for the month was 118, and as the formula states, you'll minus 20, divide by 2, and that'll get you to 49 millimeters per month. So that is the effective rainfall. So now you need to calculate the net irrigation requirement. In other words, how much is required by the plant. So the net irrigation requirement is the evapotranspiration, which is 107,52. So that's how much you've lost minus how much you've gained, which is effective rainfall. And that'll give you 58,52 millimeters per month. Okay, so the readily available water. So if you've got a soil profile, let's quickly do this. If you've got a plant in the soil and this area, then you've got the readily available water would be the soil water capacity of the soil, so the amount of water that you can have in your soil, and then the readily available is in that area of the roots. So that's why you multiply the effective root depth, and from that first slide, it's 180 is the soil water capacity of the soil, multiplied by that 0,1 0.12, which you'll also find on that first slide for the root depth, and that'll get you 21.6 millimeters per meter. So this next one is where it starts getting a bit tricky. So number 5, you've got you want to calculate the gross application rate. In other words, what this means is that you want to calculate how much water in a given time. So you want to calculate at what rate will the irrigation system deliver water to the soil or to your crop. And so this is calculated by the emitter delivery, so the amount of water that actually goes out of your emitter multiplied by the lateral spacing, which then multiplied by the wetted diameter. So as in the previous video, you can just look there as well to see how big it's the area. So this is basically the area under the line, and then above the line is the rate at which the water is exiting the emitter. Then from that, so the growth application rate is 1.66 millimeters per hour. Now we want to calculate theoretically how long a cycle should be. So a cycle is basically how long you are going to let this how long you're going to irrigate for before you have to irrigate again. So maybe more simply put, if I have a cycle length of 2 days, and then I irrigate on a Monday, that means the next day that I irrigate will be the Wednesday. So the cycle length is how long you wait, you wait before you irrigate again. And so that calculation is, or the formula is the readily available water divided by the net irrigation requirement multiplied by that wetted diameter and divided by the spacing. And so I think this one you'll get the answer for theoretical cycle length as 0.43 days. And I think this is maybe also a good way to explain practical cycle length. So if you're going to practically on a farm irrigate a orchard, irrigating in 8-hour day, calculating the whole time, your cycles won't be effective. So instead of irrigating once every 0.43 days, you will look for something that's more practical than 0.43 days. And so for practical cycle length, you can convert this into 1 day. So the last one, or the second last one, the theoretical standing time. So with standing time, what's meant by that is per time that you irrigate. So for one cycle, if you irrigate once, how long are you going to allow that system to stand? And so that is the readily available water. So in other words, this area around the roots divided by the rate at which water is infiltrating this area multiplied by the efficiency of the system. So that is because the system is losing a lot of, it's not 100% efficient, so it's losing water due to evaporation. You'll add that into the rate at which water is being applied to the soil. And so the theoretical standing time is 16.27 minutes. So that's how long you are going to let this water stand before you shut off the tap or turn off the tap. And so the last one is the practical standing time. So because to be more practical, you've changed cycle length to 1 day. That means that the duration at which you allow the water to stand before you turn the tap off this time is going to be more. So if you put that 1 day into the formula with your 16.27 minutes that you calculated divided by the theoretical cycle length, you'll get 37.84 minutes as a practical standing time.